Okay, so today's topic is STP, Spanning Tree Protocol. Spanning Tree Protocol. In switching, this is the most important protocol, guys. If you export in STP only, then you can expect in a good job in the industry. Just behalf of STP only. Okay. There is a one book just for the STP of almost 700 pages. So it's not any small protocol. Okay. If you have to learn spanning tree in depth, it will take 2 to 3 months there. But yes, after STP, you can expect in a very good job in the industry as a ALTO engineers. Okay. Now, what is STP and why we need this protocol? Okay. So the first thing, okay, why do we need it? We need it to avoid ALTO loop. To avoid ALTO loop here. Sometimes it's happened that some students at the place of the avoid, they use this word to remove. We can't use it to remove. Okay, because we can't remove any loop. We can just always avoid it. Okay, which layer? ALTO layer or L3 layer? So it's all about ALTO. ALTO means all about switches. It's not about routers. On the routers, we have loop back concept. Loops we have. But for that thing, we have another method. Okay, so spanning tree we always use to avoid ALTO loops. Okay, please note it down. To avoid loops. Okay, now the question is okay, to avoid the ALTO. So first question is, what is ALTO loop now? What is loop here? Okay, let's start it. So let's consider these are the three switches: switch 1, switch 2 and switch 3. These switches are connected like this way. This is connected with this one, with this one and with this one. We have one end device over here. What is the meaning of end device, guys? PC or laptop here. And then again we have one end device here. Okay, an end device is connected like this. Okay, now it's all about VLAN 1. VLAN 1 means how many broadcast domain do we have now? We have one broadcast domain. Now let's consider from this device. Okay, we have to transfer some data. Let's consider this is some data. So first of all, this guy will transfer the data where? It will be on this interface. Once it will becomes on this interface. So switch is all about what? Single broadcast domain. So what switch will do? Switch will transmit the data in this direction and into this direction. Clear or not? Okay. After that, now this switch will receive the data. Once this switch will receive the data, again this switch will do the broadcasting. And how many interfaces do we have? 2 interfaces. It won't send it back. That concept is not there. Okay, it will send where? Into this direction. Clear? Same data. Now this switch is receiving from this direction and from this direction. If I'm talking about from this directions, so this switch is receiving the data here on this interface. It will do the broadcasting. It will send in which direction? One into this one, one into this one. My overall concept is from this PC I have to share some data with this PC there. So when this switch, if I'm talking about this switch, is receiving the data from this in this interface, it will transmit into this direction and this direction. This is done. Second time we are receiving the data. this switch will receive the data on this interface as well. Okay, so once this switch is receiving the data on this interface here, it will transmit the data into this direction and it will transmit to this direction. So on this PC, how many times? 2 times, same data. Now, if I'm talking about when we are receiving the data on this interface, this switch will transmit into this direction, into this direction. Again, the data will be where? On this switch again. What this switch will do again? Will transmit into this direction and will transmit into this direction. So actually, we have originated the data from where? Here only at fire. Again, the data is on the same point. And last time when we received the data on this direction, on this interface, last time, this I'm talking about, okay, this switch transmit the data into this direction and this direction, this one. Again, this switch is received the data, again it will transmit where? Into this direction. Again, what this switch will do? It will transmit into this direction and this direction. So this is what? Loop. Clear? If there is a network of 20,000 devices and if there is a small loop between any 2 devices, will crash your whole network. It seems very simple, but it's very crucial for the network concept. Okay, so this is what? This is looping concept. And loop because of what? Switches, and switches are what? ALTO devices. So this loop is known as what? ALTO loop. We can't remove it. We can just always avoid it. And how to avoid? We have one protocol, and that is all about spanning tree. Clear? First note down about the loopback. What is loop here? Not loopback, what is loop? Loopback is a different thing. Is done, guys? What is loop? Okay. Now, so now we need spanning tree here to avoid the loops. We need what? Spanning tree to avoid the loop here. So overall, I'm talking about STP. STP will help us to avoid the loop. Who will help us? STP. In STP, we have one port there. Okay, that is known as block port. We have one concept there. This port will help us to avoid the loops. How will it help us. How to select, that is a different thing. Right now I'm just using one random port as a block port. Let's consider I'm using this port as a block port. This is my block port. From block port we can receive the data. Oh sorry, we can't receive the data, and even we can't transmit the data. We can't do anything. Okay. So on this interface now, you can't receive any type of data and you can't transmit any type of data there. Okay. How this concept will help us to avoid the loop now. Let's consider traffic is from this one. What this switch will do? Switch will transmit the data what? In this direction, and it will transmit into this direction. We are receiving the data on this interface. What this switch will do? It will transmit. It will do the broadcasting. It will into this direction. This is what? Block port. Can't send it. Okay. This switch is what? Receiving the data. After that, it will transmit into this direction. Data will be here. Can't receive also. So nothing is there. Avoid. Loop is avoided. So spanning tree. In the spanning tree, we have one block port concept which will help us to avoid the loops. Okay, which interface we have to use as a block port? Okay, we can use this one also. We can use this one also. This one also. This one also. So how we have to decide it? So that for that thing we have to go with the spanning tree process. There is a one process there which we have to discuss now. Okay, so like this way, your spanning tree will avoid the loops here. Overall, brief idea. First thing, what is loop? How loop will happen in the networks and how to avoid it. That is overall 3 concepts. Any doubt, any questions? So you can ask me. Why, how we have decided this is the block port, why this is not the block port. So for that we have a process, okay, that we will discuss now. Okay, that will take almost 2 hours that we have to discuss. This is clear, what is spanning tree? Why do we need spanning tree in the network?
So, but how it is affecting the network loop? What it does?
Let's consider there's a loop here. Okay, you are transmitting some data over there, and your data will roam into this concept here. After that, if loop is there, so all the switches will be engaged with your loop only. So after that, if you have any another device and if you just want to transfer any type of data over here, that is not possible. Your network will be hanged on that time. You can't transfer even a single bit of data on that time. Nothing. Whole network will be jam, or you can say hanged on that. Nothing. Clear? Now, how to start it? So for that thing, in the spanning tree, we have a process over there. There are some steps over there which we have to perform. Okay. So note down the step number 1. STP selection process. Okay. Only just write down first step is as a step 1. That's it. And note down, select the root bridge. Note down this line, this full line, only this part. Only first point, the step number 1. If we are talking about bridge, what is the bridge? Bridge is, you can say, smaller version of the switches here. Okay, so if we are using bridge or if we are using switch, it's same concept. Okay, this is done. Step number 1. Now, so we are going with this spanning tree selection process. Okay, guys, one more thing here. If I'm talking about STP, by default, this protocol is enabled on the switches. We don't have to do anything. Okay, you don't have to use even single command. Once you will connect any 2 switches or any 3 switches, automatically STP will be there. Automatically STP will be. We don't have to do anything. You can connect these 2 switches. By default, STP is enabled on the interfaces. Okay, by default concept there. How? I'll show you now. I hope you have noticed in your packet tracer. Okay. Yesterday there was a task for the spanning tree. So first, when you will connect any 2 switches first times, it's always takes time. Like see, switch 1, switch 2. Okay, and now connected both the interfaces. This is what? Red part now. This is what? It will take some time. Can you see some amber color? This is not in the upstate still. Okay, it will take 30 seconds. After 30 seconds, these ports will be in the green color. So what is going on right now? Your spanning tree is going on. Because spanning tree is by default enabled. Okay, so after some time, it will be green and then we can use the routers. We can use the switches. So what is going now? This is done. So now my spanning tree is done. Clear? So by default on the switches, we have spanning tree concept here. So that is by default and okay. Now, let's consider we are using 3 switches. Okay, we are using here 3 switches here. Loop can be possible between 2 switches also. Okay, how between the 2 switches? Let's consider these are the 2 switches here. Okay, and we are connected like this way. And we have one end device here, one end device here, and we are connected with this one, we are connected with this one here. This one. Let's consider you have to transfer some data from this device to this device here. Okay, I'm using 2 links. There is a 2 links connected there. First of all, data will be aware on this switch. Switch will do the broadcasting on this interface, this interface. This switch will receive the data on this interface. It will transfer where? To this one and to this direction. And when switch will receive the data on this interface, it will transfer into this direction or this direction again. Again is what? Okay. See. 2 switches, but how many links? Single link. Obviously on the single link there is a no loop back. Let me connect one more. Wait and watch. Even I haven't opened it CLI. Okay. By default now, out of these 4 interfaces, one interface will be in amber color. Amber color means that interface will be in the block state. Okay, because let's consider in this one, I'm using this interface as a block 1 here. Okay, so this data will be on this switch. This switch, what it will do? It will transfer the data into this direction. It won't receive and won't transmit anything. Loop avoided or not? By default. And now, can you see here? 2 interfaces upstate and 1 interface what? This one. So on this interface now, we can't receive any data and we can't transmit any data. By default. Okay, so STP is enabled by default. Clear or not? Okay, and if you will try to disable it, then loop will be there. Now, if I'm coming back here, okay, this is clear. What is loop now? How to avoid it? So we have one block port concepts there, okay, which will help us to avoid the loops there. Let's start with the selection process. There is a 3 switches, and all the 3 switches are connected with like this way. Okay. So the first step we have to select here. There's a two type of switches now. One is root bridge and second is all about non root bridge. We have two type of bridges. Two bridges means I'm talking about switches here. Okay. One is root bridge and second is non-root. In a single network, always one root bridge is there. And how many non-root bridge? N minus 1. It's all about N minus 1 here. So right now, how many switches do we have? 3. So out of that 3 switches, how many root bridge do we have? 1. And how many non-root? We have 2. Clear? Okay, note down please. Spanning tree will take some time. It's like subnetting. Okay. So within first 15 minutes, don't expect you will get this thing. It will take some time, 1 hour, 2 hours. Okay. And spanning tree will be for the 2 days, today and tomorrow. So now, how many root bridges? 1 root bridge. And how many non-root bridges? 2. If I'll select 1 root bridge, so obviously remaining 2 switches will be what? Non-root bridges there. Okay. So now we have to select. First step number 1 is what? We have to select root bridge. Can you check your step number 1, which you have mentioned last time? What is the step number 1?
Select the root bridge.
Select the root bridge. Okay. Let's consider in this classroom, I am saying we need one CR, class representative. Okay. Out of these 20 guys. Out of these 20 guys, how many options do I have? 20. Now I have to select who will be the CR. So there will be some parameters. Okay. Let's consider Mr. Rahul Gandhi and Modi is there. Okay. So out of these 2 options, we have to select one. Okay. So there is a what? One election process will be there. And what are the parameters? Votings. Who will get the maximum vote? That guy will become the PM. So that is what? One parameter. Right now, everyone is saying, just this switch is saying, no, I am the root bridge. This is saying, no, I am the root bridge, and now I am the root bridge. Because root bridge is the main bridge or main switch in the network. All communication will be happen via always root bridge. If your root bridge is down, whole network is down. This is the main root bridge. So now everyone is claiming, this is saying I'm the next PM, I'll be the next PM, and this guy is also saying I'll be the next PM. But one election process will be there, and for the election process there are some parameters. So now one election process will be there in between these things. Hope you remember when I have connected 2 switches on packet tracer. It took some time, and that time is all about 30 seconds. So what is this 30 seconds? This is election time. What is that? Election time. That will take what? 30 seconds. Okay. So first, we have to select who is the root bridge. And for that thing, we need one parameter. And what are those parameters? The parameter is that is all about switch, priority and MAC address. Actually, that is known as bridge ID. Note down please. What is that first parameter? That is all about bridge ID. Note down guys. Bridge ID. The parameter. Okay. If I'm talking about bridge ID, what is the bridge ID? It's in a combination of switch, priority plus MAC address. MAC address of switch. This is all about MAC address of switch. This is one parameter here. If I'm talking about this switch here, guys, okay, we have MAC address concept. Let's consider I'm using here MAC address A, I'm using here B, I'm using here C. These are the switch MAC address. What is that? Switch MAC address. If I'm talking about this interface, this is all about what? F00 interface. This is all about F01 interface. If I'm talking about this switch, total how many MAC addresses do we have? 3 MAC addresses. This is switch MAC address, and after that we have maybe here we are using E and F. That is all about interface MAC address. But this time I am talking about switch MAC address. There is a difference between switch MAC address and interface MAC. Both are the different things. Because most of the students, they are always confused at this point in the spanning tree. Which MAC address do we have to use it? So this time we have to use what? That's why I have specifically mentioned here. It's about MAC address of switch, not about interface MAC address. And what are the MAC address I'm going to be used here? A. A means it's all about 10. B means all about 11. And C means all about 12. Hexadecimal concept. Please note it. A is all about 10, B is all about 11, and C is all about 12. In spanning tree, we don't have any practical labs because that is by default enabled. Just we have to discuss how it works actually.
No comment there.
1 or 2 comments. Just to check it. That's it. No modifications. Nothing.
So, you told me one of the important concepts in companies and all that. Like, what do you go work there? If there's nothing.
That you will learn in CCNP, CCIE,
Okay,
those type of things.
Sure.
CCNA is just just think about that when you joined CCNA on the day one, you were not aware about all these topics, but now you have just an idea. That's it. So CCNA is very, very basic, sir. This is clear? Now, second is about switch priority. What is that priority? By default, I'm talking about, guys. By default, the priority is range always start from 0 to 65535. Okay, and by default is 32768. This is total range. Total range is 0 to 65535, and by default. So by default, what is the priority? 32768. So 32768 is present here. 32768 here only, and 32768 here only. Clear? This is by default, guys. We can change it. Okay, we can increase it, we can decrease it, and okay, we can do all type of modification with the switch priority, but we have to go with the default one. And what is the default one? 32768. Now, what is the what is the parameter I'm using? I'm going to be using here bridge ID. Bridge ID is the combination of two things. One is all about priority, and second is all about MAC addresses. Okay, priority is all about how many bits do we have? 16 bits. And in the MAC addresses, how many bits do we have? 48 bits. Okay, so total how many bits? 48 plus 16? 64 bits. So total how many bytes? 8 bytes. Note down.
Bridge ID.
Bridge ID is combination of two things. Two things are, one is about 16 bits, second is all about 48. Combine them, it's become 8. Interview question, what is the bridge ID size? So that is all about 8 bytes. Now both the parameters are ready on the both, okay, on all the switches. Now let's start the election process. Okay, right now everyone is claiming I'm the root bridge, I'm the root bridge, and this guy is also claiming no, I'm the root bridge. So in a network, everyone is saying I'm the root bridge, I'm the root bridge. But according to STP, how many root bridges do we need? One only. So obviously we need one election. So let's start the election process. Parameters are ready on all the switches. That is what? Bridge switch priority and MAC addresses, which is all about bridge ID here. This guy will send his information to this switch here. Ki buddy, no, I'm the root bridge. Okay, this guy is saying ki how you can say I'm the root bridge. This guy will share his bridge ID. See my bridge ID. What is my bridge ID? 32768. And what's the MAC address? A is MAC address. So now this guy is claiming I'm the root bridge. Now it's all about switch, and consider guys, this is switch 1, all about switch 2, all about switch 3 here. Okay, now first see now switch 1 here, switch 1 is sharing his information. What is my bridge ID? 32768 plus MAC address, which is all about
A.
And can I consider it as a 10? Clear? After that, if I'm talking about switch B, okay, switch 2 here, sorry. If I'm talking about switch 2, what is the ID? 32768 plus B. Can I consider it as 11? And then the third guy is also claiming no, my information switch 3 saying ki no, 32768, I'm the root bridge, and plus C. What is that? Can I say 11 here? Okay.
12.
Okay, sorry. About 12. This information will be on this switch as well, and will be on this switch as well. Clear? First, this guy is sending his information to the first where this guy is claiming I'm the root bridge. Will share his bridge ID here, and this all about bridge ID here. Okay, then this switch will share his bridge ID with this one and with this one, and then this switch will with this one and with this one. They will exchange with each other. Clear? When they will exchange their bridge ID, why we are exchanging our bridge ID here? For the election process, because one election is there. So when we are exchanging this information, so for that thing we have specific messages. We have some specific messages. That messages is known as BPDU. Message is known as BPDU. What is BPDU? Bridge Protocol Data Unit. Now, the switches, they will exchange its information. Guys, can I remove this portion here? This is not required. Okay, so what they are going to use now? They are going to be used here BPDU. BPDU means all about
Bridge protocol.
bridge protocol unit.
Data unit.
Data unit. Okay, data unit, which will contain what information? It all about bridge ID. This is always about bridge ID here. And bridge ID is the combination of what? About two things. One is about switch priority and second is all about MAC addresses. Okay, so what they will exchange now? They will exchange BPDUs with each other. Okay, so for the BPDU, this is a one MAC address for the BPDU guys, and this is that MAC address. This is fixed MAC address for the BPDU. This is the MAC address. BPDU MAC address. It's always fixed. This is what? It's fixed here. BPD this because now if we have two switches, I'm sending my information to you. Okay. So what I need some addresses or not. Okay. So on that time, see right now, my even CAM table is not updated yet.
Okay.
Because still in the starting you'll be just connected and still election process is going on. So up to that time there's no MAC address, nothing is there. Even I'm not aware about which MAC address are you using or not. So I have to transfer that my BPDU to you, and that is not about broadcasting. Okay.
So this message should not get broadcasted.
Exactly.
Okay, for that.
So that is destination MAC will be this one, and this is always about fixed MAC address. Because BPDU is not about broadcasting, and if broadcasting will be there, again loop will be there. Okay. So this is always about fixed MAC addresses. Destination MAC address. Two MAC addresses are there, but what is the meaning of second MAC address? Not now. After 15 days or 20 days, once you will join CCNP, you will get to know. Because there is a two MAC addresses. Clear? Because switches, they are going to be exchange BPDUs and they are not using IP addresses, and still there is a no MAC address, nothing is there. Because still election is going on in between that. So they are going to be used BPDU, and BPDUs has some MAC addresses, and that is the reserved MAC address. Now,
what basis we are calculating the priority switch? Is it the
default one.
to every switch?
Every switches. The range is 0 to 65535. We can change it. Okay. But what is the default one? The default one is 32768. Whatever is there. And right now we are talking about L2 only. Okay. But it's same on L3 as well. Where is MAC address? This is the MAC address. Yes, guys, clear? Done? Now, so we have exchanged what? We have exchanged the BPDUs. Okay, let's start with the election process. So we have exchanged the data. So now we have to decide it. So first this switch will compare, this is the switch 1. Switch will compare its bridge ID with the another switches as well. So what is 32768? 32768, 32768. Tie or not? Now let's go with the MAC addresses. We need a tiebreaker, and MAC address is always the best tiebreaker because MAC addresses are always unique. That's it. So A is what? 10, B is what? 11, C is this one. Now who's the winner here? C is the winner. But in STP, who has the lowest value, that guy is the winner. Okay, so in this one, A is the what? 10, so it means who's the winner? Switch 1 is the winner. Same here now, if I'm going back with the switch 2 will compare. Now here, if I'm talking about in this process, who's the winner? Switch 1 is the winner. If I'm comparing on this particular switch here, it's all about what? Tiebreaker, A10, B11, C12. Who's the winner? Again here switch 1 is the winner, and same again here, who will be the winner? Switch 1 will be the winner. So overall, they have decided who's the winner? Switch 1 is the winner. Okay, so it means who is the root bridge?
A.
A is my root bridge. Who's the root bridge? A is the root bridge. And if A is the root bridge, so it means B and C is what? That is all about non-root bridge. RB and non-RB. RB means root bridge. Within STP selection process, always 2 steps are there, and we are done with the step number 1. Okay, so second step is what? We have to find out best path.
Lowest value of MAC address is that switch bridge.
Sorry?
Lowest value of the MAC address switch bridge.
Who's the winner? The lowest one. Okay. So guys, bridge ID is just repeat is clear here. BPD is clear, guys. MAC address is clear. Okay, and this is now. This is clear. Okay. Now, so if I'm talking about here step number 1, so select the root bridge. Okay. So we are done with that. Okay. Intentionally, let's consider right now in this concept, A is what your A is the root bridge. Let's consider your network requirement is that because of by default concept, A is the root bridge, but my requirement is that I have to make this B switch as a what? As a root bridge here. So then, because MAC addresses I can't change in CCNA, we can't change the MAC addresses, but in the high-end classes we can change the MAC addresses also. How? Not now. So right now we can just play with the what? Priority only. Okay, so let's consider my requirement is that I have to configure, or I just want to make it this switch B as a what?
Root bridge.
Root bridge there. So then do one thing, reduce its value here. What is by default? 32768, but we can manipulate it. So then manipulate with this one and decrease this particular value. Okay, the decrement will be always 4096. If you have to decrease or if you have to increase it, so that is all about 4096. So 32768 then minus 4096. Whatever will be there, 2767 and I think 2 here. So what will be the value? That will be 27672 here. And once you will change its value, immediately the STP process will be restart again. And in the again, once they will decide it, who will be the root bridge, this will be the root bridge. Because first, before MAC addresses, they are going to compare what? Switch priority. And now my switch priority is already less. So if you are able to take the decision behalf of switch priority, then don't go with any MAC address. That is useless for us. Okay, why MAC address we have used? Because last time it was type. So that's why we came with the MAC addresses. Okay, if you are able to decide it, okay, with the help of the priority only, no need to go with the MAC addresses. Whatever is there, 2678, but that is less than 32768.
54096. 540.
It's an always decrement and increment always about 4096. That's it. Okay, this is clear. So intentionally, if you have to make, or if you just want to make any switch as a root bridge, go with their bridge, means switch priority only. One simple command is there, okay, and just change its priority.
Sir, all these are happening by default or we have
By default. But if you have to do any manipulations and all, let's consider in this one. Right now, this is my root bridge actually case. Okay, yes, consider you have to make this switch as a root bridge, so then you have to do the manipulations. Okay, so now if you know what is switch priority and how to change it, then you can do the manipulations, and otherwise no. Okay, now this is clear. Is there any problem with the step number 1? What is the step number 1? We have to select the root bridge, and what is the parameter? Bridge ID. And what is the bridge ID? The combination of switch priority and the MAC address. Switch MAC address. Okay. Write down the second step. Step number 1 is select the best path. Overall, in STP election process, there is a 2 steps. Step 1 is root bridge, find the root bridge, and second is find the best path. So spanning tree, you can write down one more use, because in the starting, on that time we have mentioned root bridge we always use to avoid the ALTO loops. But you can mention one more thing. STP we use to find out best path also. 7 to 8 different uses are there about STP, but these 2 uses are major uses of that. Just mention here to find out best path. Write down first, second this one, and write down these points as well. Yes.
Multicast.
What multicast?
Starting I've said na unicast, multicast. For the multicast, if 2 nodes are there.
Haven't used this multicast unicast today. Yeah. So from switching, how you reach there to any cast?
Sir, I just said in the front.
This is clear. Only these 3 points. Note down the 3 points. First is what? Select the root port. The second is select the designated port. And third is select the non-designated port. Oh, 1 second. Mention here as a alternate port, or you can say it as a block port as well. Okay. Actually, block is a state, but write down the block port also. Alternate port. Alternate port will provide us redundancy in the network. So you can say STP we use for the redundancy also. Third point. What happened, Aman? Hmm? For STP, use that book, How to Master CCNA. I have shared na best book for STP. For all the topics even. Okay. But STP perspective, that is the best book. Now, I'm gonna be one more thing I have to add here. One thing, 1 minute. Not this one. Okay. Now, note down the two things here again. Now, first we have port roles. What is the port roles? In networkers home, guys, what is your role? Your role is student, and my role is what? I'm a trainer here. Okay. First is what? Port roles. First port is root port. First role. The second is designated port. Okay. And the third state is what? That is non-designated port. This port is also known as alternate port, or you can say right now block port, but exactly it's not block port, but in the starting use it as a block port only. We will remove this block port from here. Once we will done with the spanning tree, then you will get to know about all these things there. Okay. So how many roles do we have? 3 roles we have. After that we have port states. Right now you are doing CCNA. You are at what stage? Stage number 1. CCNP, guys, stage number 2. So that is known as what? States here. So we have different states here. What are the first state? The first state is all about disable state. First is disable state. Second is blocking state. Third is learning state. Fourth is listening state. Forwarding state. So these are the state here. First listening, then learning. Let's consider today you are absent. So that is you are absent. Okay. Like that girl is she is not here today. Durga and Raghu. So they are absent today. Let's consider if they will join us tomorrow, and if I'll ask them to leave the class. Okay. That is the different thing. Two different things. So disable state, intentionally when you will use the shutdown command on any interface. Intentionally you are making that interface in the as a downs, okay, as a shutdown. Okay, so that concept is known as what? Disable state. Intentionally when you are making any interface as down, so that is all about disable state. Okay, intentionally when we are using the command. Okay, so what is the command for that? Shutdown. And what will be the color on that time? Red. We have colors, light colors as well. So red color is all about your interface is in the down state. Blocking state means because of STP, when your interface will be down, because of STP, when your interface is in the disabled state. So that concept is known as blocking state because of STP, or you can say because of election processing. Intentionally, see in this one, this interface in the down state or not, but it's not intentionally. This is because of your can you see block here? Okay. What is the port role? Port role is alternate port. I told you. Okay. And what is its exec state? That is all about block status. So block is what? Block is not port role. Block is what? State. But what? Yes, we can say that is one block port here in the starting, because we are in CCNA right now. Okay. So in the starting we can say block port, but exactly that is not block port. What is the state? That is block state. But what is the port? That is alternate port. Alternate port means in case, let's consider in case this one is the green interface we have here. If intentionally, if you will go to that interface and if you will make that interface in the down state, so then second interface, which is now alternate, will be in the forwarding state. That will become what? Green. So that is working as a what? We are using it as a backup port here. So backup port is always about alternate port. Clear? What is alternate port? Overall idea is clear. So what is the state? This is because of STP. In this class, I am teaching. So you are doing what? You are listening and you are learning. So that concept is known as what? Listening and learning state. When STP election process will happen, that root bridge election is done. Okay. So that is always happening what? In the listening and learning state. Listening and the learning states there. And forwarding is what? Forwarding is your final state. When your interface will be green. Okay, that is what? Forwarding state. And in the forwarding state, we can exchange the data there. In disabled, blocking, listening, learning state, we can't exchange any type of data. We can exchange the data in the forwarding state. And what will be the light color there? That will be green. And we can exchange the data. And listening and learning state, what will be the color? Amber color. That is, guys, amber color, not orange. Okay, because there is some students are always saying this is orange color. That is not orange. Don't use orange. Okay, use amber. That's it. In interviews, don't try to argue with this one, interviewers and all. Okay, because recently it's happened, one student, they just argued on the what? Amber or orange color. Okay, so you are going for in the interviews for the jobs, not for amber or orange. Okay, so don't do that. Clear this thing? Okay. Color is clear, red, and in the blocking state, again the color will be amber only. Color is what? Amber. Alternate port is always about backup port. That is all about backup port. Okay. Root port is what? Let's go with the root port. See, let's consider this is your home. You are this one here. Okay. This is street 10 and this is 12 here. Your house is at the corner. Okay, it's on the corner. Now let's consider this is one sweet shop here and you have to go to this sweet shop. Okay. So, and even let's consider one more street is there at this point. Okay, street 1, 2 and 3. How many streets? 3 streets are there. So from your home, how many exit interfaces are there? 3, 1, 2 and 3. Clear? There is a one more sweet shop here. Okay, switch shop A. This is all about B. Okay, and now you are at home. This is you, and now you have to go where? You have to go to this switch shop. How many exit interfaces do we have? 3. Let's consider once you are taking the exit from here. Okay, so your distance is about 2 km. When you are taking the distance, this interface using as an exit interface, distance is 1.5 km. Okay, there are some circles, satellites are there. Okay, and if you are going via this one, distance is 500 meter. Which is your best one? 500 meter or not? Okay, which interface you will use as an exit interface? This one only. Let's consider this is for this. If this is my destination, if this is my destination, from this interface the distance is 1 km. From here the distance is 3 km, and from here it all about 1.5 km. So which is the best one? This is the best one or not? Best exit interface is always known as root port. That is all about root port. Clear? That is all about root port. Best exit interface is always about root port.
It's like unknown unicasting. It's near. It's like unknown unicasting.
Not unknown unicasting. That is different thing. Right now we are just trying to select the best path. Once you will select the best path, on top of that it's all about anycast, unicast. That is
Which is nearby.
Yes, that is nearby, you can say. But anycast term you have to use with the V6 always, not with the V4. Okay. Check it. Anycast is always about V6, not V4.
Before data analysis, unicast.
Hmm?
Before data analysis.
This is clear? So although why I'm explaining this thing, because concept is from from this point, this source, how many exit interfaces you have? 3. Which is the best one? This is the best one. So this is all about root port. Okay, and for the one destination, always one interface will be best exit interface. Okay, 2 is not possible. In this class, if I have to select one best student, so only one student will be best, not 2, 3, 4, not like that. Okay? Clear or not? So, root port is clear. Root port is what? That is always about best measure. Root port, if I'm talking about, always present on non-root switches. It's always on the NRB, non-root switches, not on the RB. Please note it down. And 1 NRB equals to 1 root port. That's it. Note down.
Can you make it clearer again?
Just note down.
Okay.
One. Okay.
Just note down.
So full form NRB.
Non-root bridge. The same root bridge and non-root bridge. I'm just trying to save the time. That's it. We have selected 1 root and 2 non-root bridges, right? So if you okay, first done. Now open your step number 2. Check it. Step number 2. What is the first point? Select the root port. So now I have to select the root port. Root port is always present on non-root bridges. That is not possible on the root bridge. Okay, that is not possible on the root bridges. Root bridge and root port is not possible. Root bridge and root port is not possible because root will be cancelled by this root there. Just for example, okay, nothing. Two root can't be there at the same time. Okay, root bridge and root port is not possible. Non-root bridge and root port combination is there. So how many switches do we have? How many non-root bridges do we have? 2. So it means I have to select root port on which switch? This switch and this switch. So it means I don't have to select any root port on this one. So how many switches do we have now? 2. So select the root port here. First I'll go with the switch number 1. And one more thing I have mentioned. 1 now. How many interfaces do I have on this switch? 2 interfaces. But out of 2 interfaces, how many root port will be there? 1. Because one NRB has always one root port. 1 means one NRB has always one root port. So now, how many options do I have? 2. 2 options means again I'm confused. Which will be your root bridge? So again I need what? Election process or not? Clear? Means which is root? Right now 2 guys are claiming I'm the root port, I'm the root port. So now we have to decide it. Who's the root port? Let's start with the election. For election again I need what? Parameter here. Okay. What are those parameters? The parameters to select or to find out which is your root port, the parameter is this one. Okay, not this one. This is the line. Always on the non-root switches or bridges, one NRB has one RP. What is the process? What is the parameter? Note down this one. This is just selection of root port. That's it. Okay. Is this clear or not? Because now we are confused with what? Well, because we have the 2 options for the root port. Spanning tree, this is very easy. First time you are doing. That's why it's like subnetting. Okay, nothing else. Tomorrow all the things will be clear. Not today, tomorrow I'm talking about. So what are the steps, guys? This is just for the root port. And who's the root port? My best exit interface. Okay. Lowest path cost, lowest sender bridge ID, lowest port priority, and lowest sender port ID. That is steps are done, guys. Now,
What's post priority port rate?
yeah, just note down right now. Okay, I'm in HSR. I have to go MG Road. After this class, I have to go to MG Road. I have 3 options. First, I'll book Ola, which will cost me 400 rupees. Okay, then I'll book Rapido. It's like 2-wheeler, which will cost me 150 rupees. And our third option, I'll go with my personal bike. Okay, for the petrol and all will cost me 50 rupees. So 400, 150 and 50. Which is the best one? 50. How you can say 50 is the best one? Because we are using cost over there. So now, what is my source? HSR. What is the destination? MG Road. So right now, we are where? Let's consider we have one device here. Okay, and one device is on this switch here. We have this one and we have this one here. We have to transfer the data from this device to this device. Okay, remember one thing, in STP always maybe your devices are connected on the second switch, third switch, first switch, doesn't matter. Data always travel via root bridge. Directly, this is not possible. Data is always via this way. Data always travel via root bridge. So it means once the data will be reached to the non-root bridge here, so what is the next destination? Root bridge is my next destination. Clear? So right now I'm where? I'm on the what? I'm on the this switch here now, and for the I have to go where now? I have to go to the root bridge. How many exit interface do I have? 2, because data is coming from where? This interface. How many exit interface do we have? 1 and 2. So we have to find out one best exit interface, and best exit interface will be my root port. Okay, how to find out? What is the first parameter? Use the lowest path cost. Okay, path cost here. I am using here, these cables is all about 100 Mbps. I am using fast Ethernet. What is the cable here now? 100 Mbps. I can use here Ethernet also. I can use here gigabyte also. When you are, well, let's consider I have to book Ola. So Ola rent will be depends on distance or not. If I have to travel 5 km, let's consider my cost will be 200. If I have to travel 500 kilometer, cost will be different. Clear? It's not about taxi and all. It's all about distance here. So in spanning tree, what is the parameter? Path cost. So path cost always depends on speed, not on distance. Listen it. Path. What is the parameter here? Path cost. So where this path cost always depends on your speed, guys. Speed will increase, path cost will be decrease this time. Inversely proportional to each other. Inversely, if 100 Mbps, let's consider I'm at Ethernet 00 now. Okay, I'm at fast Ethernet. Speed is my 100. So if my speed will increase, speed is 1 now, gigabyte. So cost was 100. Now it will be decrease. It will be 4, 5 or something there. So speed will increase. One thing will be increase. Another thing will be decrease. If cost will increase, speed will decrease. So inversely proportional to each other. Okay. What is the cost here? That costing and all, that is resolved. Guys, this is the costing. 100 Mbps, cost is 19. 10 Mbps, cost is 100. 1 Gbps, cost is 4. 10 Mbps, cost is 2.
So bandwidth increases, cost decreases.
Inversely proportional. Okay? Not on this one. Is that visible? So according to speed, the cost is, and this cost is, guys, fixed, and which is fixed by Cisco only. Okay, we can't change this cost and all.
Speed, the bandwidth can't increase more than 10 Gbps.
That is with the Nexus, and on the Nexus there is a no spanning tree.
Oh, okay.
Cost is done. Now 100 Mbps, what is the cost here? 19 or not? Okay. Yes, done. The cost. Everyone. Now come back here. What is the speed we are using? 100 Mbps. Same here, 100 Mbps, 100 Mbps, because this is my 100 Mbps network here. Okay. So when we are using 100 Mbps network, what is the cost? 19. Now, if I'm talking about here, what are the cost between this thing?
19.
If I'm traveling via this one, what is my destination? Road bridge is my destination. What are the cost here? Cost is 19. On this path again, cost is what? 19 here, and between here again, what is the cost? 19. Now, just come back here. From here, now, I'm confused. How many exit interfaces do I have? 2. If I'm using this interface as exit interface, what will be my cost? 19. If I'll use this one, what will be the cost? 19 plus 19. What is that? 38. First, I have to reach where? To the C, and then C to the where? This one. So what will be the total cost? 38. 19. What is that step here? Lowest cost. Okay. So it means which is the best exit interface? This one here. So what is the root? Who's the root port? This is the root. Clear? This is the non-root bridge. How many root ports are possible? 1. That is done or not? So we are done with root port on this switch. That's it. Not it done. Clear? Same with the second one. This is again what? Non-root bridge. We need what? One root port here. If I'm using this one and this one, two options I have. If I'm using this interface, what are the cost? 19. And if I'm using with this one, what is the cost? 19 plus 19, 38. So who's the root port?
Both are
Not both, one. One NRB has one root port. That's it.
Same cost.
Yeah, cost is same.
But will decide.
No. See, from here on this one, on this switch, how many interfaces do? Out of these two, this is a root port. This root port is for this switch only, and this root port is this root port for this switch only.
From multiple interfaces, we will decide that.
Yes. If you have 10 NRB, so how many root port? 10 root port, because one NRB has one root port. Okay. Clear? Root port is clear or not? After that, we have to find out designated port. Can you see your second step there? In best path, what is the second step here? Select the designated port here and then select the block port. Now, one more thing, okay, one CCIE method, this is up to root port is clear? One shortcut I'm going to be explain now, how to find out designated port. That is mostly we using the CCIE here. The concept is segmentation. What is the concept? Segmentation. Segmentation means it's all about DP plus RP or alternate. Okay? Or means alternate, I can say this is all about block as well. Clear? Note down this thing. This is all about segmentation. Segmentation is the combination of two interfaces, two directly connected interfaces. These are the two interfaces, guys. Interface 1 and interface 2. Okay. So if I'm saying here DP is must actually. In a single segmentation, DP port is what? Must. And second option we have, that could be root port or it could be alternate port also. We have option. Okay. So from here, two possibilities are there in this one. If I'm talking about two possibilities from here. One is known as DP. DP means This is designated port, not your WhatsApp DP. Okay, and second is root port, and one more option DP or your alternate port. That is what? Alternate, or can I say just for this one? Block port here. Just for the understanding. Okay, these two combinations are possible here. Because on the another side, see here, we have what? We have OR option here. This is known as what? This is AND. And this is what? This is OR. Clear? So can you see in both the combination, one port is what? It's common, and which is most actually in a segment. And what is that? DP. Clear? And what is segment? Segment is combination of two interfaces. In this topology, how many segmentations do we have? Segment 1, two interfaces. Segment 2, and this is what? Segment 3. How many segments? 3 segments. Directly connected. In case, if this switch is connected with this one, so how many segments do we have on this one? Segment 1 and segment 2. Okay, two directly connected switch with a single cable. The concept is known as segmentation. Okay, note down the segmentation combination if it's pending. Interesting or not? This is clear? Segment? Now come back here. Use now segment concept. Use what? Segment concept. Use two things. One is segment and second is common sense. Two things are required here. Okay? Now, use this segment here. Okay, in this segment, I have one root port. Check your segment concept. Root port is there. What is the second option now? Designated port. Can I mention here now? Mention here. Designated port. What is this one? Designated port. This is a root port. Again, one segment we have. What will be the second one? Designated port. Clear? Come with this segmentation here. Nothing. No. Last time in this segment, we have already decided last time this was the root port. So that was very easy for us to find out. TP. But this time, nothing is there. So we have to find out. What is the possibility here? First, trying to find out the possibility. In the segment, there's a two possibility. One is DP plus RP, and second is DP plus alternate. Clear or not? If I'm going with this concept here, one is DP and second is RP. RP means root port. See, in this segmentation, RP is not possible. There is a reason. Because on this switch, we have already one RP. So is there any possibility for the second RP? No. Not at all. Is there any possibility here for the second RP? Not at all. So what is the option? Which combination? DP or alternate. One port is DP and another is what? Alternate. If out of these two ports, if I'll find out which is my DP, so obviously second port is what? Alternate port or not? So it means now what is my target? My target is to find out DP port. DP port between these two. This is clear or not? This is clear or not? Or should I repeat it again? What? See, this is the one segment. In the previous segment, okay, there wasn't a root port. So easily we have decided which is my DP. Same here, root port was there, DP was fine. But this time, there's a no root port, nothing is there. Okay, nothing is possible because right now you are not aware about which is block port. Okay, maybe this is the block port, or maybe this is the block port. Can't say anything. So now first find out which combination is possible here. On both the switches already root ports are there, so it means root port combination is not gonna be happening. What is the second option? Alternate or DP. Now out of these two ports, if I'll find out which is DP, so second port will be alternate obviously. How to find out DP? Use your bridge ID. The first option. Use your bridge ID, which is all about priority plus MAC address. Priority is what? 32768, 32768. Tie, need a tiebreaker. What is the tiebreaker? MAC address is B or C. B is lower or C is lower? B. B is 11 and C is what? 12. So this lower is always winner. So this is what? This will be your DP port. And second will be what? It will be alternate port. And what is the now this is alternate port is there. These are the what? Roles. And now if I'm talking about their states, guys, mention this thing. DP port and RP port is always in the forwarding state. DP port and RP port always in the forwarding state. And alternate port is always in which state? Block state there. That state will be block. DP port is all about forwarding state. Same here, it all about forwarding state here, forwarding state here, forwarding state here. This is all about forwarding state, and this is which state? Block state. DP and RP always in the forwarding state.
DP and alternate block state.
And alternate is always in the which state?
Block
Block state. And block state means, and in forwarding state, we can transfer the data or we can receive the data. Note on that one also. In forwarding state, we can receive or we can transmit the data. We can receive and we can transmit or we can forward it. But in block state, you can't receive or you can't transmit or you can't forward it. I'm talking about data. Data I'm talking about. Okay? Mention data as well there. Okay?
In real time, STP is going to do all these calculations.
Automatically. But if you have to manipulate anything, so before that, you should know how it's happened actually. Okay? So, just one, I just want to show you, I'm not going to be explain anything right now because just 1 second, 1, 2, 3 interfaces. 3 interfaces, oh sorry, 3 switches, connect it like this way and connect it with like this way there. Wait and watch. So STP started guys. Automatically, I am not doing anything. One port will be your alternate, and what will be the state of that port? Block port. So that's why you can say that is block port also. In the starting I told you we have to find out one block port. Okay. So this is all about your this thing. Okay. So let's consider. Is that visible or not? Just overall, it's visible or not? Okay, there's a 3 switches and all. Okay. I told you, if I have it this device and I have to transfer the data, this is the source and this is the destination. Data will be where? On this one. This is the, which is the root port. This is the root port. Data will be to the this one. Now it will be to the this device and data will be like this way. If you will try to transmit your data from here, that's not possible because this is what? Block, and this interface can't receive any type of data. Clear or not? Okay. Now, same concept or not? Okay. One more important thing here. Just use, see, this is just for, if I'm a root bridge and I have two interfaces, in front of my interfaces where I'm connected, block port is not possible. If I'm just, now let's consider guys, this is like this way. And if I'm asking, guys, which is my root bridge? Which is my root bridge? See, use two things. This is block port. On the root bridge, block port is not possible. Clear? Second thing, if you are just trying to use it as a root bridge, so in front of that again, block port is not possible. If I'm coming with this one, is there any block port? No. In front of this one, nothing is there. That is possible just in this concept. Because obviously, if this is your non-root bridge, so this is the root bridge, in front of that, that is possible. But in this topology, if you have to find out, okay, because in interview, they can ask you this question. They ask, okay, I have 3 switches and this is the block port. Now tell me which is my root bridge. So on that time, this switch obviously not possible. This is in front of this one, not possible. What are the option? This is the option. So can you see the same topology which we are using? Automatically everything is done. And this process takes how much time? It will take
30 seconds.
30 seconds. Why 30 seconds? That we will discuss tomorrow. Okay? Because actually for us, for the discussion, it took almost 1.5 hours. Okay? But still it's not completed. Because what's the reason for that? The reason is, see, come back here. In the root port, up to now we have just used what? Best path cost. What about remaining 3 things here? When we have to use it? So it means if your path cost will be tie, then we will go with the second option. Okay? So when it will tie, that we have to discuss. For we need different topologies, so that we will discuss tomorrow. I'll try to finish your STP tomorrow, but I'm not sure. Okay? Clear? So this is all about this one here. So now you can see here, this is my root bridge, this is my NRB, and this is again NRB here. NRB has always one root port, one root port. Okay? This is all about block port. Mention one more line. Root bridge always has your DP port on. Means on the root bridge, only designated port is possible. That's it. Root port is not possible again there, and there is no concept about block port. Only one concept, that is all about designated port. So in case if you are using one big topology there, and somehow just you got to know this is my root bridge, and if there is a 2 interfaces, so just select it as a what? DP and TP. Because root port and block port is not possible on your root bridge. Root bridge has always, or it's always having designated ports. That's it. Okay. So in the STP process, there are 2 steps. First is find out root bridge with the help of bridge ID, and second is find out best path. And in the best path, first find out root port. For the root port, there's 4 steps. First is about find out by the help of the lowest cost. So we have just used up to now lowest cost only. DP, you know how to find out. For that thing, you need what? We need segmentation concept, and after in the segmentation, find out DP, and then all remaining port will be what? Your alternate. That's it. I'm done for the day. See you tomorrow, same time. So today's class is done.